Hello students, today we will see the next topic is bipolar encoding. It has the two types of the bipolar code encoding, bipolar AMI and bipolar pseudo-ternary. Then in this scheme there are the three voltage levels, that means positive, negative and 0. The voltage level of one data elements is 0, while the voltage level of other elements alternatively between positive and negatives. There are two different types. First type is alternate mark inversion, that means AMI. The neutral 0 voltage represent binary 0 and binary 1 represent by altering positive and negative voltage. See, this is the representations for alternative positive and negative. This is the first is alternate mask inversion. In this example you have to provide data like 0 1. Suppose here data provided 0 1 0 0 1 0, and we have to represent by using the alternate mark inversion method. Then here the rule of this method is a neutral 0 voltage represent binary 0. That means here 0 and 1, if 0 is occur, then it represent as the neutral 0 voltage, and if alternative binary 1 in data, binary 1 is represented, then it is alternatively positive and negative voltage. That means first time positive, then second negative, positive negative, as like this. Here 0 1 0 0 1 0. Suppose here first is 0. 0 rule is binary 0 represent the neutral 0. So here the 0. Then 1 represented by alternative positive and negative. Here first time here the positive value. Then second is 0. 0 is neutral 0. Then 0 also neutral 0. Then 1. First time here positive. Then second time here negative. Alternatively positive and negative voltage provided by the binary 1. So here negative. Then next 0 is neutral 0. As like this scheme is AMI, alternate mark inversion. Then second is pseudo ternary. Bit 1 is encoded as 0 voltage. Here this is the rule for pseudo ternary. Bit 1 is encoded as 0 and bit 0 is encoded as alternatively positive and negative voltage. That means exactly opposite to the AMI scheme. Here this is the, here we have already seen 0 represented 0 and 1 represented positive and negative alternatively. Then here 0 alternatively, so first time here positive, then 1 is represent as 0, then 0 represent alternatively first time here positive, then second time here negative, then third time here positive, here negative. So here 0 is represented as and 1 is represented as 0. So this both 1 is represented as here 0 0. This is the bipolar encoding, and it having two technique, alternative mark inversion and pseudo ternary. Then next topic is transmission modes. The transmission of binary data across a link can be done in either parallel or serial mode. As shown in figure, here data transmission divided into two types, parallel and serial transmission, and serial transmissions is divided into synchronous, asynchronous and isochronous. Then the transmission of the binary data across a link can be done in parallel or serial modes. In parallel mode, multiple bits are sent with each clock tick. That means in the serial mode, one bit is sent via each clock tick. Then second is the parallel transmission. There is only one method to send the data. In serial transmission, there are three methods of the sending data, that means asynchronous, synchronous and isochronous. Then first is parallel transmission. The binary data consisting of zeros and 1 may be organized into groups of the n bit each, and by grouping we can send n data bits at the times instead of one bit. Normally we can set one byte at a time. So but here by using the parallel transmission we can send by grouping the data n number of data at the time. So here this is called as the parallel transmission. The parallel transmission, if you want to send 8 bit at a time, we require 8 wires on the one for each bit, and this parallel transmissions is one of the most important advantages is speed. But here one of the disadvantages is also parallel transmission, that means the cost. Here the parallel transmission uses n communications line and it is expensive, so it is used for only short distances. This is the parallel transmissions. Here number of bits transmitted at a time, here one of the sender and one of the receiver. Then second type is serial transmission. The serial transmissions communication, the data bit are transmitted serially as per name over a common communication link, one after the another. Basically it does not allow simultaneous transmission of data because only a single channel is utilized, and thereby allowing sequential transfer rather than simultaneous transfer. Serial mode of the communications widely used because of the following advantages. First is reduced cost of cabling, lesser number of the wire is required as compared to the parallel transmission. Then second is reduced crosstalk, lesser number of the wires result is reduced in crosstalk. And third one is inherent devices characteristics, that means many devices are inherently serial in the nature. These serial transmissions occurs in one of the three ways, that means synchronous, asynchronous and isosynchronous. Here the representations for the serial transmission, one of the sender and receiver, and here communication data bits are transmitted serially over a common communications link, that means here the data bus. Then first type is asynchronous transmission. In asynchronous transmission, timing of signal is unimportant. Instead information is received and translated by agreed upon the patterns. Patterns are based on grouping the bits into the bytes, bit stream into the bytes. Generally, every group is of 8 bit and every group is handled independently, relaying it to the link whenever ready. Without regard to a timer, so it is the unimportant for timing. To alert the receiver to the arrival of a new group, an extra bit is added to the beginning of each byte. Usually 0 is called as the start bit. To know the receiver byte is finished, additionally 1 bit is appended at the end of the byte. This is called as the stop bit. And the start and stop bit and gap alert receiver about the beginning and end of each bytes. This mechanism is called as the asynchronous because at the byte level the sender and receiver do not have the synchronize. Here to alert the receiver, sender and receiver, the new group, an extra bit is added to the beginning of each byte. Here 0 0 0 0. Then usually 0 is called as the start bit, and to know the receiver byte is finished, additionally 1 bit is appended to the end of the byte. Here these are the 1 byte, 0 means start and 1 here the stop bit, and this is called as the stop bit. The start and stop bits having the gap alter the receiver about the beginning and end of the byte. Here the byte level sender and receiver do not have the synchronize, but within each byte receiver must still be synchronized with the incoming bit stream, and this is the some synchronization is required, but only for durations of the single byte, and the receiving devices resynchronize at one onset of the each new byte. So this is the asynchronous transmission. Second type is synchronous transmission. In synchronous transmission, the bit stream is combined into longer frames, which may be contain multiple bytes. Each byte is introduced onto the transmission link without a gap between it and the next one. It is left to the receiver to separate the bit stream into bytes for decoding purpose. In other words, data are transmitted as an unbroken string of 0 and 1s. And the receiver separate that string into the bytes or characters. It needs to reconstruct the information. Timing becomes very important here, and therefore because of the accuracy of the received information is completely dependent on the ability of receiving devices to keep an accurate count of bit as they come in. And the advantages of synchronous transmission is speed, with no extra bits or gap to introduce the sending and the remove sending end and remove the receiving end, and by extension with fewer bits to move across the link. Synchronous transmission is faster than asynchronous transmission. Here the diagram shows the synchronous transmission, and this is the direction flow. Then isosynchronous transmissions is designed to provide a steady bit flow for multimedia applications. So that means in real time audio and video, in which uneven delays between the frames are not accepted. Then synchronous transmission fails. Here for example, TV images are broadcast at the rate of 30 images per second. They must be viewed at the same rate if each image is sent by using one or more frames. There should be no delay between frames. For this type of application, synchronization between characters is not enough. The entire stream of bits must be synchronized, and the isochronous transmission guarantees that the data arrives at the fixed rate. For the multimedia application, synchronizations is characteristics is not enough, so the entire bit stream will be synchronized, and that is why the isochronous transmission guarantees the data arrives at the fixed timing. Then trunks. There has been a rapid development in data communications over the past few years, including the creation of the concept trunking. A trunk is a physical path, or a trunk is communication system that is designed to handle many transmission simultaneously, and that interconnects major switching centers, nodes. Depending on the system, trunk may carry transmissions in analog or digital forms. Transmission contents may include voice, text, then computer program, images, video, or the some control signals. Here one of the example for trunk is a physical path, and this depending on the system, trunk carry the transmission in analog or some digital format also. This transmission contains including some voice, like the convention between the telephone system, text, computer program, images, video, or the control signals. Trunking is a technique used in the data communication transmission system to provide many users with access to a network by sharing some multiple lines, frequencies. As the name implies, trunk, the system is like a tree with one trunk and many branches. Trunking is commonly used in very high frequency, that means VHF, radio and telecommunication system. Trunking can also define as a network that handles multiple signals simultaneously, and the data is transmitted through trunking, can be audio, video, controlling signal, or some images also. Cisco network having the trunk port and access port. A trunk port is a port that is assigned to carry the traffic for all the VLANs that are accessible by the specific switch, a process known as a trunking. And as an access port, transport traffic to and from only the specified VLAN allotted to it. Usually an access port will have a single VLAN setup on the interface, and it carries traffic for just a single VLAN. If the VLAN for an access port is not configured, the interface can carry traffic using only the default VLAN, which is usually VLAN 1. Here in this diagram, VLAN 1, VLAN 2, and here the router, switch, trunks and switches. Then VLANs are local to each switch database, and VLAN information is not passes between the switches, and trunk it provides the VLANs identifications for frames traveling between the switches, and VLAN trunking protocol, that means VTF, VTP, the protocols that switches to use the communicating among themselves about the VLAN configurations. These uh, trunk link provide the VLAN identifications for framing traveling between the switches.